Welcome to this quick tutorial on building robust web APIs with ASP.NET Core 9 and MongoDB using the repository pattern. In this tutorial, you will learn how to efficiently structure your API to separate data access logic using the repository pattern. We will integrate MongoDB as our database for modern NoSQL approach to data management. We will cover a step-by-step implementation, starting by setting up the database, creating repositories, and writing everything into your ASP.NET Core API. By the end of this video, you will be able to build APIs that are scalable, maintainable, and perform well with clean, testable code. So in this tutorial, we're going to cover how to manage or maintain a MongoDB database collection that stores information about products, which identifies by the name and the price, and of course the identity, which is the ID. The API we're building today will be a very basic API to maintain or manage data into the product collection and the MongoDB database. And the product is identified with a name, price, and an identity or an ID. And we're going to build the different CRUD operations, starting by the post, the list, the get by ID or the read, the update, and the delete. So we have 5 different operations that we're going to do to make our API useful, and we can consume it using different frameworks like Angular, React, or mobile apps. So we're going to do a quick test or a quick demo. So this is the post. This will handle posting the product. So I'll post product 123. Then we have a price. So notice here that if I refresh, you will see only 5 products, but when I post this product, you will have 6. As you can see, the product is added, and when we refresh in the database, you will see that the new product is added, and we can always retrieve that same product. So let's retrieve the list of products. So now my product is here. Then I can use the get by ID method to retrieve that same product, and it's going to be here. We can also update the product by using the same ID, so I can take it from here and then put it in my put request. So that's the ID, and then I'll put the ID here, and I'll put, let's say here instead, I'll just put product 99, and then I'll put, let's say 300 as price. And then when I post this, notice that this product will be updated. As you can see, when I refresh here, you will see that my product gets updated. And then I can also delete that product by just using the delete API or the delete API endpoint. So I'll take that same ID and then I'll supply it here. And this is actually Postman. If you don't know how to use Postman, please check out the documentation postman.com, and you will see that it's very, very simple to use and to create these APIs tests. So when I delete, my deletion worked successfully. So when I refresh here, so that object will be gone. That's it, what we're going to build today using ASP.NET Core and MongoDB. So we first need to set up a MongoDB database either locally or online. So the easiest approach is to go to mongodb.com and provision a database on the cloud there. And it's very, very simple to do. I have already covered that in our recent video. Please check the description below to get the link to that video and watch it to see how we can provision a MongoDB database in a couple of minutes. It's very simple. And once you do that, you'll have a connection string that we're going to use in our project. Before we begin building the API, we need to have Visual Studio installed. If you don't have it already, you have to go to visualstudio.microsoft.com, and then from there you click on download. Then it will download the setup for you. So you just click there and it will start downloading the setup. Once it's done, you click on the setup and you follow along to install Visual Studio. Make sure to install .NET Core and the web components to follow along with this video. The next thing is that we need to have MongoDB Compass. You can search MongoDB Compass download, and this is actually a database explorer. So once you download it, you'll be able to connect to any database using connection string, and then that database will be explored this way. So you'll have access to your database, your collections. You can edit, you can add data, you can export, and a bunch of other things. You can delete records. You can always create new databases here or new collections. It's very user-friendly application. And also, we need to have a MongoDB database provisioned either locally if you want to have a local server, or on the cloud if you were to go to mongodb.com. That's where you provision the database quickly in a couple of minutes. If you want to know how to do that, please check out the description below for a link to a video in which we have provisioned a MongoDB database under mongodb.com. If you want to install your local server and work locally, you can always download MongoDB server. So you can just search for MongoDB server, download, and then you go to a community server, and then here you have to configure it yourself. It depends on your operating system. So you have a version for Windows, and just download the MSI, or download the zip file, and then it will be already installed. You just open it. So it's up to you to decide. For us, we're going to go with an online MongoDB.com database that we already provisioned, and we're going to use that in our project. One last thing we are going to use today in our tutorial is Postman, and Postman is very popular API testing platform. So you can just download it from here, and it's very basic. So it will ask you to log in. You just need to log in for free, and then download the free version for your Windows. That's it. So it's very convenient application to test web APIs. We already showed you how we used it here, and we're going to create all these, let's say, operations or HTTP requests along in the video when we finish creating the API. So stay tuned and let's start. So let's start building our API, and the first thing we need to do is start Visual Studio and click on Create New Project, and then select the Web API template. So you can just search for Web API here, and then select ASP.NET Core Web API. Make sure to select that template, then hit Next. After that, you have to name your application. So in our case, we're going to just say ASP.MongoDB.API, and then leave everything else to the default. Click Next. After that, you have to make sure to select .NET 9 standard long-term support if you want, and then click on Create. It will take a couple of seconds, and it will set up the project for us. That's it. So our project is ready to go. So we will have a default controller and a default, let's say, weather forecast model that we're going to delete. We don't need it. So I'll just delete that controller, and I'll delete the file from here. So now we have an empty API. There is no controller, there is nothing. We're going to start building our API by introducing the model, the controller, and the repository for MongoDB connection. And of course, we need to install the MongoDB driver. So the first thing is to go to the project and enter dependency. You click on package, then click on manage NuGet package to install the MongoDB driver. So that's just search for MongoDB here. Then make sure to select MongoDB.driver, install, accept or apply, then accept. So that's it, MongoDB is installed, and we are going to start building the API. The first thing we need to do is to add the connection string to our appsettings.json. So in the last video, or in our recent video, we have already provisioned the database under mongodb.com, and we have copied the connection string and we put it under Notepad. So make sure you do that so that you use it in our API. And this connection string will go under appsettings. So appsettings is the setting file for our API. We're going to introduce a new JSON entry here. We call it MongoDB settings if you want, and then that is going to host a JSON object. So we'll have the connection string, and this is the connection that we got from mongodb.com. I already copied it, and then we'll have the DB name, so database name if you want. Then here we're going to call it MongoDB demo. So you call it whatever you want. And that's it for the connection string and the database name. We now have to create a class to access this setting, and to do that we're just going to create a new folder here called settings, and this is going to contain all setting classes or all settings attributes. So I'll call it settings, and under that I'm going to call or to add a class called MongoDB settings, similar to that entry that we have there. So I'll create a class that have the same name. Then we have the attributes of type string that have that same name. So I'll just have connection string under this. So I'll say prop, hit tab, and then say string, then paste that, and I'll duplicate that and have the other, which is the database name. So these are the two settings that we need for our database, or to connect to configure our MongoDB database. To use these settings, we need to bind them under the program.cs, so that we bind the class to that configuration section. And to do that, you just head over to program.cs, and then here we're going to bind my settings so that I have access to them. Bind MongoDB settings. And to do that, you just need to say builder.configure or builder services.configure, and then supply the class called MongoDB or MongoDB settings. So just take this class and then have it here. After that, you have builder dot configuration dot get section. So we're going to get that section using name of class, actually. So we're going to get access to that section, which is the MongoDB settings. So this line of code is responsible of getting the app settings entries into the program.cs, so that we use them later when we connect to the database or when we connect to the MongoDB database. So that's it for binding the settings. And now we are ready to go ahead and start implementing the repository pattern. The repository pattern is a design pattern that abstracts the data access logic, providing clean interface to interact with the data source. In our case, it's a MongoDB database. It actually separates the business logic from the data layer, ensuring separation of concern, abstraction, and testability. So in our case, we're going to have a repository pattern to help access the MongoDB database, and to do that, we'll just head over to our project and add new folder to put the repository pattern implementation classes there. So we're going to call it repository, and under that we'll have two classes, or one of them is an interface, which is a generic interface, and the other one is a concrete implementation of that repository interface. Repository, iRepository for interface. And then we'll have a concrete implementation, which is a class called Repository. Then later on, once we finish these two classes, or this interface and this class, we'll have different, let's say, repository for each entity. So we'll start by creating the iRepository, and to do that, we'll just change this to an interface, and this is actually a generic repository that accepts any type or any class, where T of type class, and then this class here will be the concrete implementation of that class. So it's going to be a generic class that implements iRepository of T, where T is a class. So in this iRepository, it will be just the methods we need to access the database, which are the CRUD operations. And this repository class will be the implementation of those methods, or the definition of those methods. In other words, iRepository is an interface that defines a contract for a repository. A repository is a design pattern used to abstract the logic required to access data sources, providing a consistent way to interact with the database regardless of its type or implementation. In the context of iRepository, it typically defines generic CRUD operations like create, read, update, delete that are commonly needed for interacting with the data source. The actual data access implementation is handled by a concrete class, which is in our case the repository that will implement the methods. So we are going to start adding the method within the repository. Then we're going to define each method within the repository. So as you can see, I have added the different method that we're going to need to get the data or read the data, create, update, and delete. And in the repository, we are going to define each individual method. So first we need to click here and then implement the interface. So we have all these methods, and we're going to start implementing them one by one. But before that, we will need to have access to the database using the connection string and the database name. And to do that, the only place that you can start doing or using is the constructor. And in the constructor, we'll need to have access to those settings from appsettings.json. To do that, we'll need to have iOptions of, this is iOptions of MongoDB, which is the class that we have there. So this is our settings class, and this is the one that will give us access to those settings within app settings. So that's the class, and here we can name it settings. Then we will need two things or three things. So access to a client or a Mongo client, access to the database and using that Mongo client, then access to the collection we will need for the repository under that database. So we will have client instance of Mongo client, database instance, and collection from the database. So this will need the connection string for that. So we will create client, var client is equal to new Mongo client, and this interface or this class need the connection string, so we can get it from settings.value. As you can see, it's typed already, so it will help retrieving that connection string. And same thing, we are going to create an instance of the MongoDB database, and to do that, you just need to use that class or that client.get database, and we'll use the settings to get the database name. So settings.value.database name in this case. So these two settings are actually here, and we created a class to access them, and we bound them in the program, so they are ready to be used within our repository. Then finally, we have to have access to the collection, and to do that, we need to have a read-only private property here, and this is going to be my Mongo collection of type T, and we're going to call it collection. So this will give us access to the collection or to any collection under MongoDB. So we need to get it from the database. So we're going to say this, or collection is equal to database get collection of type T, and then we're going to name that collection based on the class name or the class type name. So type of T dot name. So meaning that each collection or each class that we're going to create, or each entity that we're going to represent, like customer, product, order, or whatever, will have a collection named the same name as your class name. So we're going to do that later when we create product repository, for example. So now we're going to implement each method, and I'm going to pause the video and come back later to explain. So I'm done implementing all the methods. So we'll start by the get all async. So this will just retrieve, and when we submit true in the find, it will get all the list of all the collections, collection list, if you would. Then we'll have retrieve by ID or get by ID. This will just convert the string, which is the ID, to an object ID or a MongoDB object ID. Then retrieve that object using the ID attribute, which is defaulted to _ID. After that, we have the create async. It's just going to insert one async using the collection. So this is built in from the MongoDB library. Then we'll have the update by ID or update async. So this we'll need to convert the string, the ID from string to an object ID, then use that object ID to update one async or replace one async. After that, or finally, we have the delete async. So the first thing we need to do is to convert the ID from string to an object or an object ID. Then we are going to use that to delete one async, or to call delete one async from the collections. Now that our repository pattern is implemented, we're going to start adding the entity and the entity repository. In our case, we're going to model a product entity, and that product entity will have three attributes: the ID, the name, and the price. And we're going to create a repository for that product. So the first thing we need to do is to start by adding the entity. And to do that, I'll just go create a new folder here called entities. So these are the models that we're going to save or store in the database. So these are the domain model, if you would. So you can have customer, product, orders, and any other collection. So I will create a product, let's say entity. So it's a regular class, but with a specific, let's say, annotation. So it's going to be have the ID. So we're going to say prop string ID, and that's it. So this is our model or our class, and our collection will be called class, like I mentioned. So when we create the repository for this product, we will use this entity name to name the collection automatically, and that's what we have done within the repository, if you remember correctly. So here we said that we'd like to have the type of T name. So we'll see how the product collection will be created based on the class name. So here we're going to have some annotation for the JSON ID or binary JSON ID. So it's coming from MongoDB library, and then we'll have this as the object ID, which is going to be stored as our object ID. So JSON represent or representation is going to be JSON type dot object ID. So this tells MongoDB that this is our ID that is auto-generated by MongoDB based on the GUID or global unique ID. So it's going to generate global unique ID whenever I create a new entry. And this annotation is actually the identity of our, let's say, product entity. So now that our product entity is ready, we're going to create a new repository for this product, and that repository will actually extend the repository class and interface or implement the interface iRepository with the generic type. In this case, is our entity called product. So I will go and create a new class here called product repository. Inside this product repository, we'll have the extension of the iRepository, which is generic type, and we'll have a product repository that implements that new interface. So public I, so it's an interface, I product repository, and this product repository will implement the iRepository of type product this time, so I know the type, and we're going to use our entity. So now that's that for the interface. Then we're going to implement this interface in our repository, and this is going to be the repository of type product. So it will extend the repository of type product this time, and at the same time extend it with the iRepository or iProduct repository. Then here you will be asked to have the constructor at least, and the constructor we will have the settings once again. So if we really need these, we will use them. Otherwise, it will call the base like the base of this repository by supplying these settings. So now whenever I create a new let's say instance of this repository, we'll have access to the settings, and that will supply those settings to the parent class, which is the repository, and everything will be bound to the database, and we'll have access to the product collection. So since once we instantiate this, let's say this repository class, it will create a new collection for us based on the type, which is in our case the product entity or the product class. So that's it. Now we need to supply these two, let's say the iProduct and product repository into our, add them into the dependency injection container. And to do that, you just go to your program. Then here we will add them to the services. So we're going to just add, command here, add the repository. So the first thing is to get the generic repository and add it to the service. So builder.services.addScoped. And then we're going to add type of. Whenever I look for my repository of type any, I need to supply the type of repository in this case. Then we're going to add the product implementation or the product repository. So add product repository. And to do that, we'll just say builder.services.addScoped. This time, whenever I look for iRepository or iProduct repository, if you want, we will supply product repository. So this is how to register the repository or the product repository. So that's all for adding the repositories to the container or the dependency injection container. Now we are going to use this product repository in our controller, and to do that we'll just create new controller here, and we're going to call it product. So it's an API controller, an empty API controller. Then click add, so that you name it products controller. And within this product controller, we have the, let's say, product context. So it's going to be private, read only, iProduct repository, and this is going to be a repository. Then we're going to use that to, or to use this actually to access the repository or the product collection. And this will come from the constructor, so come from the dependency injection. So in the constructor, we'll have access to the repository pattern by just say iProduct. This is going to be supplied by the dependency injection container, and I'll put that into my repository. So that's it. Now I have access to the collection or the repository or product repository that will give us access to the collection called product under the MongoDB database. And now we are going to create a different method to retrieve information, create information, delete information, and update information. I'm going to add them quickly, and then we're going to explain them one by one. So now I have added all the methods. So as you can see here, get all, so it will just get all the information. Then we'll have get by ID that will retrieve just a specific entry by ID. We have the post that will call the create from that repository. Then we'll have the update that will just call update async from the repository, and we have the delete that will call the delete async from that repository. As you can see, the repository pattern simplifies our work, keeping the controller clean with only one single dependency, which in our case, the product repository. Now imagine if we had to create an instance of the MongoDB client, access database collection, and implement each individual method like we did here for this controller or for any other controller when we have multiple controllers. It will quickly become cumbersome and repetitive. So the repository pattern is a very simple way to help preventing that. And as you can see here, we have one let's say, a dependency to this controller, and the controller is very, very clean. Now we are ready to test our API, and to do that, we just need to click on run from here. I think I have a validation issue. Let me just check that the JSON is valid. I think we have an issue with the JSON file. I think this is missing the comma, so I have to add it. Then I'll restart. Okay, so now it should be running as expected, and we'll receive this, let's say, API link. So to test the APIs, there are multiple ways to do it. So in .NET Core 9, there will be no support for Swagger, so there will be no Swagger interface, but there is the API Explorer that you can use to test your API. And to do that, you just head over to Views or View menu, then Other Windows, then look for Endpoint Explorer, which is this one here. After that, you'll be able to open this, let's say, collection of endpoints within our API, and you will be able to start running or trying these APIs in the in your HTTP. So you can just click on generate request here, and then click on send request to retrieve the information. So in our case, we don't have any product, so it will return an empty array. Now we can try the post product, delete, get, and put, but it's kind of inconvenient to use this API Explorer. If you want to use it, you're free to do so. But for me, I prefer to use Postman, and I'm going to show you how to add these, let's say, 3 different or 4 different or 5 different operations to Postman, either manually or automatically. So we're going to proceed manually this time and add them one by one. I'm going to quickly demo how to add these requests in Postman. So you just need to install Postman. Once you install Postman, just run it. And then here we are going to you can say allow here. Then here we'll have our collections. I'll go ahead and create new collection. So my new collection will be a blank collection. I'm going to call it ASP.NET and MongoDB. Tutorial. Then under that collection, we'll start adding some requests. So the first request will be get all or get async or get all. And then we're going to take that link from the API. So this is our link. After we run the API, this command line will open and give us a link. Then here we'll supply API products, then run. So this will return an empty list. You can always save this and it will appear here. Then we're going to create a new, let's say, request under that collection. We're going to call it post this time, post product. And this is going to be the same link, but instead of get, we change the type of the request to post. And then we need to supply a body of type raw JSON. So here we need to supply the product name. Product 1, then we'll have a price of type decimal, so price. So we'll have a random price there. Now when I post, I should be able to create this product under our MongoDB database collection. So when I hit enter, I think I have an error and that says that the ID is required. And to solve this issue, you just need to go and make that ID optional. So I'll go back, just stop the execution, then go back to the product and make this ID as optional parameter or optional attribute, and that's it. So now when you run and post information, you will be able to. So let's go back to Postman and save this request. Try to post again. As you can see, my product is added, and we'll go ahead and check the product list or product collection in our MongoDB Compass. And to do that, since I'm connected to the database already, I'll just go ahead and refresh. So click on that option menu there, then refresh database. Then my MongoDB demo database will be created for me, and then I'll have a collection that shares the same name as the entity that we have created within our code, which is the product entity. So this is the entity, and like I mentioned, so this entity name or the class name will be used to create the collection. And as you can see, my product is added here. I can always go back to the list of products to see that my product is actually there. So this is get by or get all products. So it will supply a list, and as you can see, I have one product. Then we'll create another request to get by ID this time. So this will be get by ID, create new request or add new request, get by ID, then just paste that same link. And we're going to supply the ID as a parameter here. And this call will call this method actually. So as you can see here, I will call this controller method, which is get by ID. So this is what we will call when I send this request. So I click on send, and then it will give me one entry, which is my product one entry. Then we will have another query, which is going to be edit or delete. So we'll start by creating the edit, the update or edit, add request. And this time we'll say update product. And this is going to be different. So we'll have put operation instead. And then we need to supply the ID here and the same object that we're going to update. So I'll take this object. We need to supply it in our body. Select the raw. Then here I will just keep the same ID. I don't care about that. I will update this product by just adding updated tag if you want, and then update this to 1, 2, 3 to just have a different product. So as you can see here, I'll have them side by side. So this is my current product, and this is my like new version. So when I send this, I'll be able to see that it's updated correctly. Then here, when I refresh, I'll see that my product is updated. Then the last query that we're going to do, so this is going to be put, so let me just save it. The last query we're going to do is actually delete by ID, and this is going to be a very simple query. If you want, I'll just click on add request. Then here we call delete product. And then, like I mentioned, it's very simple to just send a delete operation, and this method will actually call this action, which is delete product. Then when I supply that, it will delete, and it will give me a message saying that it successfully deletes the product. When I refresh in the database, I don't see my product. I can always create that product back. So I have all those, let's say, requests, so I can always create multiple products. Then I go back to check that the product is actually added. You can see here, so it works. API is working as expected. And yeah, that's it. That's it for this tutorial. We're going just to have, we're going to just discuss how we can extend, let's say, the product repository to have more product specific, let's say, function or actions within the repository or the product repository. And to do that, you'll just need to, let's say I would like to retrieve a product or products within a range. So I can create a new method there and then implement that method within my product repository implementation. To do that, I'm going to create a new method within my iProduct repository, which is the interface, and that method will be of type task, and it will return enumerable of type product in this case. Then this method will be called get by price range. Let's say get by price range. So this is not a common method, and it's specific to the product. We'll say decimal min price, max price. And then here it will ask me to implement that interface. So I'll just click on implement the interface. Then here I need to create a query to get the product or products within that range of prices. And to do that, it's very simple query. So we'll just return await, since it's going to be async. Then I will use the collection since I have access to it. So the collection is private. I can change it to public within the repository so that I can use it. So public. Then here in my repository pattern, I can access that dot. In this case, it will be find. And then I supply a predicate. Going to supply a predicate there, and it's going to be price is more or equal than min price, and p dot price is lower than min dot or max price to list async. So this implementation is very, very specific to the products, and we can use this, let's say, get price range within our controller by simply calling a new method and just say get by price range. So to do that, we'll just say this, and then supply min price and max price. And these are the two parameters to our API. I'll say decimal min price, then decimal max price. Then here, instead of this method, we're going to call get by price range, and we'll supply min max price. So that's it. Now when we call this method, we will be able to get by range, but yeah, you get the idea. So this will work, and it's actually specific to the product, and depending on the need or the requirements of your entity, you will have to have different implementation or different repository per entity, and then you extend that in your entity specific repository. If you find this tutorial helpful, be sure to subscribe, hit the notification bell, and leave a comment if you have a question. Thank you.